The reason for factoring is this problem. If it appeared in an exam, I believe 90% of students would be stunned, thinking there must be a mistake in the problem. They'd think it should be a minus sign here, not a plus sign. If it were a minus sign, we could use the difference of squares formula. But in fact, this problem really does have a plus sign. So how do we solve it? Today, let's analyze it. Is ax to the fourth power the square of ax squared? Is 1/16 the square of 1/4? The first part is squared, the second part is squared. What do you think the middle term is? Isn't it 2 times a squared multiplied by something? Isn't it 2 times 1/4? Isn't it multiplied by 1/4? 2 times 1/4 is 1/2, so we've added an extra 1/2 x squared, but we need to subtract 1/2 a squared to balance it out, right? Not a single cent is left. All right, let's continue. Completing the square gives us ax squared plus 1/4 all squared minus 1/2 x squared. How does this change? This is very important. It's actually the square of the square root of 1/2 times x. Why is it the square of the square root of 1/2? All right, next, using the difference of squares formula, it becomes its square plus 1/4 plus 2 times the square root of 2x, all multiplied by x squared plus 1/4. Subtract the square root of 2 over 2 times x, right? Okay, then let's tidy this up. This is the quadratic term plus the linear term, square root of 2 over 2 times x, plus the constant term 1/4. Here, this is ac squared, the quadratic term minus the linear term, square root of 2 over 2a and 4, then plus the constant term. So you really need to master this method.